It's like, what is this, Lady Ada?
Hey, everybody, welcome to the wonderful weekly show and tell hosted by your gracious host, me, Lady Ada, and Mr. Lady Ada. We're here from the Adafruit factory, but this is your half an hour to shine. We are actually the audience, and you, the viewer, the makers, the hackers, 3D printers, crafters, sewers, knitters, electronicsers, solderers, whatever it is that you're building and making, we'd love to see it because we love to see what you're working on. We're very thankful for this year. So we have some people, when we call on you, show off your project, we gotta get Area 750. So take 2-3 minutes to demo your thing. And let's kick it off with Scott.
Scott, what you got going on this week?
Hey, sorry. I thought I was second.
Oh, sorry. Yeah, probably.
You're number one in our book.
Sweet.
Oh.
All right. First, I wanted to show my Hacktoberfest shirt off that I got courtesy of DigitalOcean. Basically, if you did 4 pull requests in the month of October, they sent you a free shirt, which is cool. That was a great way for us to get new people into contributing for CircuitPython. And it includes me too, which is cool. The other thing I wanted to do is I've been working on kind of making our development process for both CircuitPython and libraries a little bit better. And so what I've done is I've I've been working on speeding up Travis today, which is the thing that runs every commit on CircuitPython. It makes sure that we didn't break anything in the process. And it then gets followed up by Rosie, which is what runs tests on boards, which I'm also trying to fix. But basically what I've done is this one here is one I ran previously, like an hour ago, but didn't have my optimizations. And it ran for 15 minutes before it finished. And I wanted to get that down. So I did a couple tricks. One, I checked in the Debian package so we don't have to download it because the downloads for that package were taking up to like 7 minutes. And then I also split the test into a bunch of tinier tests. So you can see here that I actually have one job now per board. And then I also have a QEMU and a Unix test as well. So those all get run in parallel. Which means that although the total time here is 26 minutes, which is actually longer, because it happened all at once, it only ran for 9 minutes. So that's cool. And then the other thing I wanted to show off lastly was the AdaBot account that I just made for GitHub, including this awesome, awesome icon. Actually, I should follow AdaBot here. And AdaBot has liked CircuitPython, but the reason that I made this account is we will start doing automatic releases of the CircuitPython bundle. So I'll have a script on the same Raspberry Pi that's running Rosie that just updates the bundle, commits a new update, and then does a release all automatically once a night if there's something new. So that will be super cool, and that should be coming in the next few days.
That's cool. Robot friend.
Yeah, look, it's friendly. It's a friendly helper robot.
Yep, of course.
All right, thanks for the updates.
Okay, I'll show I have just a T-shirt share too. So you get one of these if you start Hackaday, I guess. So I got one of these. This is the Hackaday SuperCon. They sent me out one because I couldn't make it out there, but they sent me out a shirt. That was very nice of them. Okay, I think it was Eric who was there. Okay, now Pedro, what you got printing this week?
Guys, hey, hello everybody. So we got an update to our telescope adapter project we did quite a while ago. So I updated all of the reference designs so they're all sketch driven now. You can just input any dimensions to your cell phone so you can update those to match. And because the iPhone X came out, I wanted to test out using the telephoto lens on the Zoom eyepiece that comes with the first telescope that we have in this shop. So I tested it out and did some really cool shots so you can see on this week's 3D Hangout. And I guess you'll be playing the video later on today. But they're way more better than the ones that when we did, I think it was like 4 years ago, which it should be since, such a huge gap between the sensors. So the optical image stabilization definitely works out on that. No chromatic aberration on any of the edges. So that looks really good. And since I already had the design for that, I went ahead and updated all of the bumper designs as well. So I was able to do a lot better, more design techniques for the fillets and the chamfers that are going into all of the insides here. before we did it with like 123D design, so nothing was with sketches. Everything was all like buoying and cutting like geometry out of the way. It's super like inefficient. It's like
caveman 3D modeling.
It's definitely like caveman.
Smashing a bunch of primitives.
Yeah. So so I did the NinjaFlex design for that as well. Go over some of the techniques for compensating for materials that are elastic, because obviously all of the design guidelines that Apple puts out for all their cases, they're definitely going to be different for that. So go over to that on this week's 3D Hangout. And of course, also updated the PLA design for that as well. So nice, simple little bumper that one of the cool features, I guess, of it is being able to stand on your side, since the phones haven't been able to stand on their side since iPhone 4, I guess, because of the chamfered edges. So that's a cool feature for that. And of course, it's offering protection for shock and all that cool stuff. And the color that I went with is this really lovely caramel color that we have in the shop. It's the NinjaFlex, the 85A shoulder hardness. And it looks like leather. It looks pretty good. We originally got these for doing the prosthetic hand projects. So it definitely have a nice assortment of like skin tone colors for that. So you can check out all of the files. Of course, we released all those, updated all of the guides for that. And you can get all the download links on learn.adafruit.com. Check it out.
All right, we'll be playing the videos, and I have a terrible idea. Could you make a case out of the notches? Because there's some people who don't like the notch. You could just make the case out of notches all the way around, so it's notches. It's just made out of notches.
So it's just obscuring the screen more than it is.
Yeah.
It's basically evenly obscuring the screen.
Yeah, there's just notches.
There you go.
That was a terrible idea. Stay tuned for next week of terrible 3D printing ideas. Okay.
Thanks, guys.
Next up, Rebecca. Hello, Rebecca.
Hey, Rebecca, welcome
Unmute your mic
back.
and show us your project.
Hi. It's been a while, but I've been working on an escape room, and I have some pictures from that. So I'm gonna share screens.
We were just talking about that in our weekly remote team meeting. Lowe's Hardware is doing I saw it on like Twitter. They have a little video where they're doing like Lowe's Black Friday escape room and buy stuff at Lowe's and escape from Lowe's or something. So
Cool.
yeah.
So I've been working on a piano. This is an actual upright piano that was just left in the space that we're using. And I labeled some keys that I wanted to use to make a melody to unlock a door.
That's cool.
And then I lifted up all the keys in that section and started soldering wires onto little breadboard buttons and hot gluing them down. So there's a lot of wires, but they're all hot glued into place so that they're high enough when you press the key down, it'll actually hit the button, but still low enough that it doesn't obstruct the way the piano works. So you can still play the piano. There's just now buttons under all the keys.
That's cool.
And I soldered all the wires from a bunch of them together because I wanted them to all detect the same thing. And there's now a huge mess of wires underneath those keys. But it does work, and it can unlock a door by just playing keys, which is really neat.
That's cool.
That's cool.
Lots of movies have that,
and that
thing where you have to like press the one key or like do
Like
something.
press a tone, musical thing.
That's great. When you're finished with it, a little video and send to us, we'll post it up or send us a link to it.
Yeah, of course.
Okay. Coming soon, it's the escape room at the Steinway store.
Yeah.
Where are we going? Okay. I think there's one of those in New York.
Yeah, there's a Steinway factory.
Yeah.
I used to live near Steinway.
All right, next up, Matt. Welcome back, Matt. Unmute your mic and show us your project. Yep.
Hey guys.
Hey, how's it going?
So I made a GPS tracking device with the parts you guys sent me.
Cool.
It's
Ooh.
so it's the Raspberry Pi 0W, the Fona 808, a RGB LED, and the Pi OLED, and some batteries. And it uploads to the Adafruit IO server.
Cool.
That's cool.
It can run on this battery, which is 5,000 milliamp. It can run for 12 hours, and on a bigger battery, 10,000 milliamp, you can actually run it for a full day.
That's
rad.
great. So you can at least do, well, there's geocaching, then there's tracking stuff, and then
Yeah.
there's,
You can also do like cellular communication.
yeah,
That's pretty cool stuff.
that's really cool. All right,
Nice.
Matt, well, what's your next step with this? Is there going to be a
I'm working on a guide for it the way it is right now. I was thinking of attaching some other sensors to it so I can make like a mobile data logger of some kind.
That's cool.
Nice.
There was an article about like data logger devices in the Feather top marks, high praise. So.
And the 0W has, of course, more capability.
And then we have I/O, so you can actually use it and stuff like that. Okay. All right. Well, thank you so much, Matt. We'll keep fueling you with projects, but if you want a sticker, of course, email support@adafruit.com and we'll send you out.
Thanks.
Okay. Next, Giovanni. Hello, Giovanni. Unmute your mic and show us your project.
Hey.
Hey.
Hi. So this is my first time on here, so a little nervous. Sorry, guys.
You have a great workbench. Look at how organized it is.
Oh, thanks. A little disorganized, but working on it. When about a month ago, my friends and I were talking about AirPlay and Raspberry Pi and Spotify devices and stuff like that, and trying to make like a Spotify Connect device. And after some Googling, I found this great GitHub to DT Cooper where he made a Spotify Raspberry, I think is what he called it, where it's a Spotify Connect device. So this is my first Raspberry Pi project, but it's just a Raspberry Pi Zero with the Primaroni hat on it. And it's really cool because it's similar to Boomi. Once I saw Boomi, I was like, this is awesome. In Spotify, it will show up as a Spotify Connect device.
That's cool.
And then you can just play. So I have it hooked up to the speaker here and just play music right from
Oh, that works.
right from Spotify to it. And then once I saw Boomi, I was thinking this project could then be modified to the AirPlay. So that's going to be my next thing, is using Boomi's guide and also using AirPlay. So this way you have multiple options, either if you're a Spotify person or Apple Music, kind of go from there.
That's super cool. And then you can put in any type of enclosure and all that other stuff.
Yep. And then
Nice work.
All right. Well, you get an As Seen on the Show and Tell sticker. Email support@adafruit.com, and we'll send you out an As Seen on the Show and Tell sticker. And will you come back as you do the other parts of the project?
Definitely.
Okay, because you can keep collecting stickers.
Yes.
There's no limit. All right, Giovanni, thank you so much. All right, next up, Dave. Hey, Dave.
Welcome back.
Oh, Dave, your mic is still muted.
We can't hear you.
Yeah, we can't hear you, Dave. But
you want to do Baker charades? You just hold up your project. We'll guess what it is.
yeah, we can guess what it is if you want, or we can try. You want us to come back to you, Dave?
Well,
Yeah,
looks
we'll
like
just
a
come back to
Raspberry
you.
Pi type thing. Yeah.
Okay. Okay.
Next up.
Okay. Next up, Dannon. Dannon. I mean, your mic shows your project.
Thing from the Snap Circuit set. It's project 47, this or that. If you use this switch, the light stays on. This one, it only turns on when you hold it.
Nice. That's
and then
awesome.
me and my dad 3D printed some stuff like poop emoji #2 trophy. and then the one piece fell into this. And then we were starting to make one of those light things that we 3D printed, but except the one piece broke off.
Printed.
Yeah, that part broke off.
That's okay. You
That's
can always
cool.
3D print another
You
one.
can always make a new one. All right, well, excellent work. So that's project 47. Did you do the other 46 projects? Yeah. Okay.
Around.
That's fine. You don't have to go in order. That's just
Yeah.
cool.
You can do any order you want.
Well, if you email support@adafruit, we'll send you out a As Seen on the Show and Tell sticker.
Okay.
Okay, good work. These are great projects.
Good work, Dannon.
I like the little trophy.
Yeah. #2.
I like a #2 trophy. All right. Okay. Nah,
Thank you.
thank you. All right. Next up, Coding Pro.
Hello. As I showed you last week, I had my Minecraft in real life kit, and I made the board magnetic finally. So now all the pieces stick, and I'm working on some connectors to figure out the best way to connect to different like components together, like a light or something. And so now I'm gonna try to get. I can put the redstone block anywhere on the board, and it won't fall off.
That's cool.
Good.
And same with the other parts I'm gonna make. Like I can put them anywhere. Sort of like a board, but like the whole board isn't, but only certain like parts of it. So it's sort of like a chalkboard, but or a whiteboard.
That's very cool. Well, there's plenty of room for a show and tell sticker if you want to collect one, of course. So email support@adafruit.com and we'll take care of you. Good work. Keep coming back. Your projects are great. Coding Pro.
Yeah. I love seeing the progress.
All right. Next up. Okay, Adam. Take us away into the world of the tiny and the microscope.
Yeah. So before we do that, I just want to say really nice shirt, Phil.
Oh, yeah. It's so embarrassing when you go onto a show and tell.
I have to email everybody before the show and tell, make sure we don't wear the same thing.
This is an okay shirt to have the same shirt on. It was totally worth it. So the conference was great. I highly recommend anybody who's interested in what Hackaday does and just meeting everybody from Hackaday to go. It's a ton of fun, and a lot of great discussion happens there. But let's get on to the electron microscope. Under it right now, we've got the BME 680, which is a pretty dang cool sensor, as Lamore can attest to. And we're actually going to look at one very specific part of it right now for two reasons. One, I know how it works. Two, it's the only part I can reach with my stage. A ball bearing fell out of the stage, which means it can't move as far as it should be able to normally, which is really unfortunate. So we're going to look at this part over here. Now, this is the tin oxide sensor, and this is responsible for detecting the volatile organic compounds, so things like alcohols or so I can't remember any of the other ones right now, but we're going to zoom in on that.
Carbon dioxide, basically, yeah, any alcohols or volatile organic compounds or ethanols.
Things that can oxidize something is basically how this thing works. And we'll actually talk about why that is pretty quickly here once I get my zoom controls under control. So we zoom in here, we see this kind of little lump in the middle right here. Let's make sure you can see that on camera. This little lump in the middle is actually a tin oxide. And so what this tin oxide does is it heats up to about 400 degrees, and what happens is the oxygens in the air binds with the tin oxide and creates an insulating layer inside of it, and the insulating layer prevents current from traveling through it. So the less oxygen you have bonded to the tin oxide, the less insulation you have, and the more current that flows through it. But any volatile organic compounds that come along and stick basically to this, or that pull oxygen away, that pull the oxygen is sticking to the tin oxide on it, off of it, then allows more current to flow. So by measuring current flow, you can figure out how many VOCs, as volatile organic compounds are called, are actually sticking to this thing. So we can zoom in and we can see there's actually quite a bit of detail fairly deep down. I'm operating at about 16,000 times magnification right now. I'm going to focus it real quick. But it's a pretty interesting process. I don't know. I'm trying to figure out exactly how they actually manufacture this right now, but you've got so much detail. I'm at a 3,200 times magnification, so about twice what you can see with an optical microscope. But it's just it's weird to have a semiconductor process that results in this kind of texture forming. So I want to figure out more about what type of process that is. Yeah. But it's what you can do with an electron microscope is really kind of reverse engineer how they built semiconductors.
Yeah, it's like an organic process. I mean, it all works, but it's probably created in a way so you can get repeatable results. That's
yeah,
neat.
no, it's always fascinating how they it looks like so random, and I don't know if they hard set values in the firmware on board the other chip on this thing. If you look on here, this is only
completely uncalibrated. What you have to do is you have to calibrate each sensor. Like you heat it up, and you get the resistance value after half an hour, and that's your baseline. Okay,
so that makes complete sense then for this kind of process. Yeah. But that's only one thing that a sensor does. This also does a lot of other stuff like pressure, temperature, and humidity, and that's all taken care of by this block of silicon over here. And I don't have all the technical specs on how this works yet, and I can't actually move my stage that far over because a ball bearing fell out, and it's just all sorts of things are jammed now. So this is as far over as I can move my stage to see it. So I can kind of zoom into the middle of it here and see just the edge, but I can't really get any good detail on it, which is kind of unfortunate. But
This is great because we like write software for this stuff. We make this stuff, and then you can see how it was made. That's really
no, that's one of the most fascinating things to do is kind of start to look at different things, and you can really learn a lot about the manufacturing process from this. So,
cool.
I was talking with some people at the SuperCon, and they actually reverse engineered a insulin pump by reading the fused states on the silicon using an electron microscope to dump the firmware to break the encryption on the wireless control for it, so they could do their own closed-loop control system for it.
That is so cool.
It's some insane stuff you can do with these tools. I'm really getting to the point now with this one where I can start to do those things.
Yeah, it's neat that eventually the atoms give up the secrets. Like
yeah, no, it is really just that. I mean, it's an interesting tool to get working, but it's a really powerful tool once you do. So.
All right. Well, thanks so much, Adam. Keep coming back.
Yeah, thank you.
We will find the secrets of these tiny things. All right, C-Scott, play us out. Let's see if C-Scott is.
You there?
Yeah. What you got going on?
Am I working? There we go. I don't know what was happening. Okay, been away a few weeks, but a few things have happened. I probably showed you guys this before. This is a Crobiax voice card. My recreation of an OBX voice card, but this one is going back to using the custom envelope generators since the firm in Latvia is making the chips again. So back to me real quick. I got them, and I've tested them already, and they work perfectly fine. I thought you would be interested to know that the prototype, the pre-production models, they do just like they did 40 years ago. They're a ceramic chip body with a metal cap on it. What they do is they hand bond these chips to their pins, and then they inspect the metal layers that actually connect the circuit elements together before they cap it and send it off. That way they can verify, they probe the die to make sure that this chip works before they send it to somebody to evaluate. And I've tested them already. So the boards for this will arrive Friday. I mean, this is a vintage. This is an original one from 1979. And the next time you see me, which will probably be after Thanksgiving, I'll show you my modern version of it. Now, the other thing I wanted to mention was, since I have a day job now, they had me come up with a way. They wanted a touchscreen video playback system. Like, well, that's a Raspberry Pi. This is the machine I use to, I don't know if you can see this much. I'm going to try and angle so there isn't. But what I have so far is these small thumbnail images are, you press it to play a video, and it'll cycle through it and complete and come back to the main screen. I also have it so you can tap secret locations on the screen and it pops up a keyboard. You can look at the networking, bring it up and down. You can drop out to the desktop and make changes.
I had to do that with a kiosk a long time ago when I made kiosk stuff. That's yeah.
Well, the interesting thing about this is I wrote all this in Python, which I'd never used before.
Woo!
So, you know, I come from an era where an object-oriented language just wasn't popular. And you know, this is all about objects and classes and namespaces and whatnot. It took me a little while to learn the ropes, but once I got it going and enough Google searches to figure out why certain threads were terminating in the wrong place and whatnot, I got it all to work. So, you know, it checks to see if there's a USB stick in there. If it is, are there videos on the stick that it can use? I don't have it ready yet, but I have a little 8-input switchboard that's going to plug into the GPIO header so that you can use hardware buttons to do the same thing that touches do, if for instances where you're not able to touch the screen. I'll just keep you up to date on that, but that's what I've been doing.
That's super cool. And then, like, now that you've learned Python, you do CircuitPython.
Oh yeah, I was going to get one of those Playground Expresses in and start tinkering with it with the CircuitPython and see what I can do.
Drop me a note. I'll send you out a set of things that run.
All right. Yeah, I'll email you later.
Okay. All right. Didn't forget Dave. Everyone thought we did.
Let me click off, guys.
All right, Dave. Dave's gonna play us out. Oh no, Dave, your mic stopped again, Dave. We just heard you and then it stopped.
Phew. Rough.
I heard Dave.
I think it was Dave.
Yeah, I heard Dave. All right, Dave, we got to do maker charades. You want to do maker charades? Hold up the thing.
Hold on.
Yeah, hold up.
Hold on.
Okay. Okay, this is the board you made.
Okay, so it's got the trinket M0 and it's got a regulator of some sort. Okay, so 9 volts in,
2 caps.
5-volt regulator, and then the VL53 lock, so it's like a distance sensor. This is some sort of weird distance, maybe measuring thing, like he's measuring distances,
lights,
and then there's lights, and so it tells you how far something is. Maybe the farther it is. Yeah, maybe.
Oh, he's going to do demo. So is it, okay, near.
Whoa, too close.
Far. Oh, when it get close, and then it turns, oh, that's cool.
Oh. Okay, but only when it gets close enough.
Yeah.
But I wonder what it's for.
This is a space invader.
Mm.
When it invades your space.
Okay, it does.
All right, see, we don't need words.
Yeah.
We got like 30 frames per
Yeah,
second.
for that.
All right, Dave.
All right, nice
Well,
work.
thanks so much. We'll send you a sticker or more hardware or all those things. Thank you so much, Dave. All right, thank you, Rebecca. Thank you, Pedro. Thank you, Matt. Thank you, Giovanni. Thank you, Dave. Thank you, Dannon. Oh, look at this. Forgot to introduce myself.
It's Mia. Hi, Mia.
Yeah, it's Mia. Hey, Mia. And Caddy the cat. See, Scott. Cutting Pro. And Adam, we're here every single week. Thank you, everyone, so much for making this the best half an hour. If we don't see some of you next week, because it's holiday time, we'll be here.
Thanksgiving.
Happy Thanksgiving. We are thankful for all of you making this thing happen every single week and 24/7 in Discord. And, of course, all the makers around the world making stuff and sharing. So thank you.
Thanks, everybody.
All right. Bye, everybody. See you on Ask an Engineer in 2 minutes.